Hey guys, this is our fourth video for our summer learning session, and this will be our last video. It is on quadratic equations. Before spring break, we talked about absolute value equations, and we talked about quadratic equations, and we talked about the transformations that could occur. We talked about shifting them up and down, left and right. We talked about the vertex of those absolute value and those quadratic equations. And we talked about what it would look like to move them from one spot on a graph to another. This first page of our quadratic equations section is a little bit of a review for you as far as vertex form here and standard form. This intercept form right here is something we've not really talked about, but if you look here, it says y equals a times the quantity of x minus p times the quantity of x minus q. Well, those two quantities, x minus p and x minus q, are the factors of that quadratic. And to get our solutions to the quadratic equation, if it's in intercept form, which looks like factored form, all I would have to do is set those factors equal to 0 to solve. So if you see something written in intercept form, that is the easiest quadratic to solve. Now, if we read on down through our notes, in the equations above, you have two variables, an x and a y. In each case, there's an x squared term, an x term, and a constant. The solution in each case has been to draw a graphical representation of the relationship between x and y. For this set of notes, we will be looking at methods for solving quadratics for the specific values of y. And those specific values of y are called the solutions, the roots, or the zeros of the quadratic. And they are also called the x-intercepts of the quadratic. So we have vertex form, intercept form, and standard form. Obviously, the easiest of these to solve is intercept form because you already have your factors, and we can set those factors equal to 0. By setting the factors equal to 0, we find the x-intercepts, which is where it crosses the x-axis. Now, if we were in class, we would take quite a bit of time, and we would talk about all of the different methods to solve quadratic equations and when certain methods work better and when certain methods aren't the best. But since this is our video learning section, we're going to focus on the one method that works for everything is called the quadratic formula. Right there. If you look at the top of the page, it says there are 4 methods used to solve a quadratic equation. We have the square root method, completing the square, the factoring method, and the quadratic formula. Only the quadratic formula works for all types of quadratic equations. And when we say all types of quadratic equations, that means we could end up with real roots or we could end up with imaginary roots. You know, we've talked about the imaginary number system. We talked about the complex number system. We talked about I. In class, we've already talked about what I and I squared and I cubed and I to the fourth look like. And we can have solutions to our quadratics that have an I in them. And we use the quadratic formula to solve those. So all of that being said, is this page right here gives you an example of what we would do by taking the square root of both sides, and that was the first method. And then we have another example that says solving by factoring, and that goes with our polynomials unit that we did first, our first 3 videos. We would factor out the quadratic, and we could use grouping to factor it out. And when does the method of factoring work? Well, it works when the quadratic is factorable. But sometimes we don't want to do grouping, and we would rather use the quadratic formula. There's a little video, if you Google the quadratic formula, or if you search for it in YouTube, it's the quadratic formula being sung to Pop Goes the Weasel. And if you play that video a couple of times, I promise you will not ever forget the quadratic formula. So here's the formula. It's x equals negative b plus or minus b squared minus 4ac, the square root of that, all divided by 2a. This little section right here, the entire numerator is over 2a. The entire thing is over 2a. You have to make sure that you remember that you take the whole numerator and divide it by 2a. When you take the ACT, this formula is not given to you. It's one that you need to memorize. That's why I said if you'll look up that video where Pop Goes the Weasel, it'll help you remember it. And then you'll have it kind of committed to memory for the ACT. So now let's flip over to page 3 of Quadratic Notes. The formula is printed at the top of page 3 again. And if you look, I've made you some notes to hopefully make it easier for you. It says the quadratic formula, x equals negative b. I said this negative sign must always be written down. If b happens to be a negative number, for example, if b was negative 5, then you would write the opposite of negative 5, which means you would have two negative signs to end up with a positive 5. Because remember, the opposite of negative 5 is positive 5. So let's talk about this A, B, and C and where they come from and how we put them into our quadratic formula. So if you look right here, it says solve the following quadratic equation using the quadratic formula. So that's going to be our first example. And I've made you a note that says it must be in standard form. Standard form is ax squared plus bx plus c. A is the coefficient of x squared. B is the coefficient of x, and c is the constant and standard form means that ax squared plus bx plus c is on the left of my equation, and that whole thing is set equal to 0. So if I look in this example 1, that is not in standard form. To get it in standard form, I need to subtract 7 from both sides, and I need to rewrite my equation. So I need to subtract 7 from both sides, and then my new equation would be x squared minus 5x minus 7 equals 0. Now it is in standard form. And I need to write down my a term, my b term, and my c term. So my coefficient of x squared is 1. And then my coefficient of x is negative 5. And then my constant is negative 7. Remember, the sign in front of a number goes with it. Something that you've heard a lot since probably 5th or 6th grade. So remember, the sign in front of the number goes with it. So it's written in standard form, and so now I know what A, B, and C is. Right here, it says write the quadratic formula down. And then I wrote above it, actually write the formula down every single time. There's a couple of reasons for that. It's a lot easier to fill in your quadratic formula if you're looking at it. Also, the more times that you write it, the easier it will be for you to commit it to memory. And that's what we want to do. We want to remember it. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, our second step says substitute the values of a, b, and c into the formula. So x equals, and then b is negative 5. So remember right here where it says this negative sign must always be written down. So there's a negative sign that's part of my formula, negative b. And then my b value is negative 5. So anytime I have a value that's negative, I need to put it in parentheses, plus or minus the square root of, I have a negative value, it needs to be put in parentheses, so negative 5 squared, minus 4, I'm going to write over my notes that I wrote down on your paper. It's okay. I'll tell you what those say in a minute. Minus 4 times A is 1 times C is negative 7. All of that is underneath our radical sign, and then it's all divided by 2A. And now remember I said I was going to tell you what I wrote. I wrote over it, but I was going to reread it to you and tell you what it meant. It says some people find it easier to find the value of b squared minus 4ac, what's underneath our radical sign, first to make the quadratic formula easier to use. So we would have x equals the opposite of negative 5, two negatives, remember we end up with a positive, 5 plus or minus the square root of, and instead of 2a right there, I should have written down 2 times 1. So let's go ahead and figure out what this b squared minus 4ac value is. Let's figure out what this value is under our radical. Let's simplify that first. So I would have negative 5 squared. Negative 5 times negative 5 is 25 minus 4 times 1 is 4. And then 4 times negative 7 is 28, negative 28. So I have 25 minus negative 28, and that's all underneath my radical. And then I have, let's see, 25 minus negative 28 is 53. So that's sometimes easier. So 5 plus or minus the square root of 53, all divided by 2. So now then, can I take the square root of 53? Is that going to give me a whole number? That's the question I need to ask myself. In this case, if I take the square root of 53, I'm not going to get a whole number. So I have two solutions. How do I know I have two solutions? Because of, let me change my color. Green looks good because of this plus or minus sign right there. So I have two solutions because I have 5 plus the square root of 53, all divided by 2. And then I have 5 minus the square root of 53, all divided by 2. So we have a radical answer, and that's okay. But this is one of those where using the quadratic formula is extremely helpful, and we don't have to try to figure out the exact value of where they cross the x-axis. So right here, we have types of solutions. Well, we can have real solutions, which will be real numbers, part of the real number system, or we can have complex solutions, which would be those solutions that have an I in it. And we talked about that a little bit ago because I said, remember, we've talked about the complex number system already in class, and we've talked about the square root of negative 1 is equal to I squared is equal to negative 1. I cubed is equal to negative I, and I to the fourth is equal to positive 1. So we can have an I, and our answer and our solutions would be part of the complex number system. So in this case, we had two real solutions. So let's turn the page to page 4 of our quadratic section. So we've got another example. Solve the following quadratic equation, and then we'll identify our types of solutions. So this is example 2. And right here I wrote you a little note, write in standard form. That's very important. So we'll come over to the side. We have 4x squared minus 10x equals 2x minus 9. Well, remember, standard form is going to be ax squared plus bx plus c equals 0. So I need to move my 2x over to the left by subtraction. And I need to move my negative 9 over to the left by addition. So draw me a line there. So 4x squared, bring that down, Negative 10x minus 2x would be negative 12x. Nothing plus 9 would be plus 9 equals 2x minus 2x is 0. Negative 9 plus 9 is 0. That's what I want. So now it is in standard form. So we have 4x squared minus 12x plus 9 equals 0. And I can identify my a, b, and c value. A is the coefficient of x squared, which is 4. B is the coefficient of x, which is negative 12. C is the constant, which is 9. Here we go again, writing that quadratic formula. The more times I write it, the easier it is for me to commit it to memory. So negative b plus or minus the square root of b squared minus 4ac all over 2a. We're going to substitute our values for a, b, and c into the formula. So x equals the negative sign that's out in front of my b, and then my b value is negative. It goes in parentheses, plus or minus the square root of my b value is negative. It goes in parentheses, minus 4 times my a value is 4 times my c value is 9. I never ever draw my radical sign long enough. And then all over 2a. Simplify. I write that 2a every time. It would be 2 times 4. So to simplify, I still have x equals the opposite of negative 12 is 12, plus or minus. We're going to come over to the side and we're going to work out this radical, this negative 12 squared minus 4 times 9. So negative 12 squared is positive 144. Negative 12 times negative 12 is positive 144. And then 4 times 9 is 144. So then I have the square root of 144 minus 144, which is 0. Can I take the square root of 0? You could pause the video for a minute if you wanted to, and you could pick up your phone or your calculator and you could try that out. Remember, the Desmos app will help you out as far as that goes. So you can try to see if you can take the square root of 0, which would be 0. So now I have x equals 12 plus or minus 0 divided by 8. Well, if I said 12 plus 0 divided by 8, and if I said 12 minus 0 divided by 8, am I going to end up with the same answer? Yes. So in this case, I have one solution, and that one solution is real. It's part of the real number system, and I can write it as a fraction. 12 over 8 simplifies to 3 over 2, or I could write it as a decimal. So in this case, if I have one solution, that means my quadratic touches my x-axis in one spot, and it doesn't cross my x-axis in multiple spots. So now let's go to that last page, quadratics section. We have one more example, example 3. Why don't you pause the video for a minute and see if you can work this one out on your own. See if you can write the quadratic formula down and work that out on your own. Check to make sure it's in standard form first. So let's see. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. When I look at this example, it is in standard form, so I don't have to rewrite it. My coefficient of x squared is 1, my coefficient of b is negative 6, and my constant is 10. Substitute those values. X equals the negative sign that's in front of my b, open parentheses, my b value is negative, plus or minus the square root of My b value is negative. It goes in parentheses. Minus 4 times 1 times 10. All divided by 2 times 1. Simplify. X equals a negative, -6. And the opposite of -6 is +6. Plus or minus. I'll come over to the side and I'm going to simplify this -6 squared minus 4 times a times c. So I've got the square root of 36 minus 40. I've got the square root of -4. Look at that. I'm going to have my first complex number system answer. I can't take the square root of -4. Instead, I have the square root of -1 times the square root of 4. The square root of -1 is I. You remember that from our complex number system. The square root of 4 is 2. But instead of I2, we always like to put our coefficient first, so it would be 2i. So now I have x equals 6 plus or minus 2i, all divided by 2. Well, now I can make two fractions. I have 6 over 2 plus or minus 2i divided by 2. Well, 6 over 2 is 3. So I have x equals 3 plus or minus, and then 2 divided by 2 is 1, so it would be I. That plus or minus right here means I have two solutions. Let me write that in the right spot. I have two solutions. My solutions are x equals 3 plus I, x equals 3 minus I. But they are in the complex number system because there is an I in our answer. This is the end of our quadratic video. I believe in your packet I may have put a page in there about the discriminant. The discriminant is the value that's underneath our radical. I'll see if I can get a short, quick little video up about that in the next day or so. But this ends our quadratic video. Thank you.